When a heavy-lift rocket tears through the atmosphere, it relies on millions of real-time calculations to stay on course. Every trajectory and orbital insertion is an act of pure mathematical precision. The mathematical foundations for those calculations trace back 15 centuries to a 23-year-old student in northern India. Reaching orbit requires a flawless mathematical foundation. And speaking of foundations, today's video is brought to you by Taku Property Consultancy, where modern architecture and structural integrity meet. That student was Aryabhata. He was the architect who drafted the blueprints for how we understand physical reality today. In the 5th century, stargazing was a mix of observation and strict dogma. The global consensus placed a stationary Earth at the absolute center of the universe. In India, the sky could be a terrifying place. When the sun or moon darkened during an eclipse, popular belief held that invisible celestial demons, Rahu and Ketu, were physically devouring the light. Astronomers who wanted to look deeper hit a hard mathematical wall. They lacked a numerical language capable of expressing massive cosmic distances, as tallies and simple fractions were insufficient for the scale of the stars. To solve this, a young Aryabhata traveled to the intellectual capital of the ancient world, Nalanda University. He understood that before he could map the stars, he first had to invent the numbers required to count them. His first major contribution was popularizing the decimal place value system and treating zero as a distinct mathematical tool. By treating zero as a rigid mathematical placeholder, an equation could instantly scale. Adding a zero increases the value tenfold, allowing for massive, complex computations. This section of the infographic highlights his calculation for the constant pi. He worked it out to 3.1416, a value that remains accurate for modern computers. He then defined Chaya and Kocha, the earliest known forms of sine and cosine functions. These are the geometric tools used to calculate angles and plot distances. Centuries later, sailors used these exact trigonometric functions to chart their positions on open water, turning abstract math into a tool for global trade. With a functional mathematical language established, Aryabhata challenged the core assumption of his era. He argued that the Earth was not stationary. He used a simple analogy to explain this. A man in a moving boat sees stationary objects on the shore moving backward. This same logic applies to the cosmos. The stars appear to move westward because the Earth itself is rotating eastward on its axis. The bottom right of this chart shows the result of his modeling. He calculated the Earth's circumference at 39,968 kilometers, nearly identical to modern satellite measurements. Without a telescope and relying on pure geometry, he decentralized humanity's place in the universe. He then turned to the mythology of eclipses, replacing demon folklore with mathematical mechanics. He introduced Chaya Kutaka, or shadow play. He proved that an eclipse is simply one celestial body blocking the light of another as their shadow cones intersect. NASA historians note that his geometric model was 99.8% accurate, allowing him to predict the exact start and end times of these cosmic events. By replacing divine terror with predictable mechanics, he helped establish the foundations of the scientific method on the Indian subcontinent. At just 23 years old, he compiled these theories into the Aryabhatiya, condensing his entire universe into 121 Sanskrit verses. After his death, his manuscripts traveled along the Silk Road and into the Islamic world. Arab scholars translated the work as Al-Arjapar. These texts provided the framework for modern algebra and were eventually integrated into Arabic texts that circulated throughout Europe. This transmission gave European astronomers a refined mathematical toolkit for calculating orbits, providing a critical link in the long chain of ideas leading to the scientific revolution. In 1975, India launched its first spacecraft and named it Aryabhata, a permanent tribute to his foundational role in science. The scientific revolution is a shared global heritage, built upon the mathematical blueprints drafted by an ancient Indian teenager who dared to calculate the truth.